It's kind of like microwave popcorn. I got to wait for a few seconds
A
before.
few seconds, yes. The popping has to speed up a little
That's
bit.
right. Okay, I want to be mindful of people's time. So,
I
welcome
think
to the latest product quality cleaning webinar. You're in for a special treat this time. We've thrown away the PowerPoint slide deck, and we're having a panel discussion on navigating the present and future solvent regulations. Please use the Q&A button on your screen to send your questions directly to the panelists, and we'll do our best to get to all of them. But if we do not, don't worry, we'll follow up with you afterwards. That is, if you ask your question without using the anonymous click button. If you do that, then we have no idea who you are. We're blessed to have Shelley Lucis as our moderator for our discussion today. Shelley has over 20 years of marketing experience and has been with Hubbard Hall since 2017. And she was recognized for her forward thinking in the metal finishing industry in the 40 under 40 class in 2021. And so, Shelley, I'll turn it over to you.
Darren, so today we're going to be talking about how manufacturers are facing concerns and uncertainty in the current regulatory environment. Today I'm joined by four expert panelists, Barbara and Ed Kingsburg from BFK Solutions, Darren Williams of Sam Houston State, and my colleague at Hubbard Hall, Jeff Davis. Together, we'll delve into the complexities of challenges and opportunities as we explore the intersection of economic, environmental, and logistical factors that are shaping the landscape of solvent regulations. First, I want to go around our panel quickly to get everyone's expertise in cleaning processes and practices. Jeffrey, I'll start with you.
Welcome. Thank you for having me, Darren. I think this is a very opportune time to talk about some of the solvents. I'm Jeff Davis. I've been with Hubbard Hall for a long time. Going back to the early 80s, I've been involved in the whole litany of different solvents and alternatives and trying to help people navigate through them all the way from back in the days of Freon and 1,1,1 trichloroethane, all the way to today's designer solvents and trichlor and perc and methylene and all the other, everything in between. So thank you for having me.
That's great.
Thanks, Jeffrey. Barbara and Ed, if you want to let everyone know who you are.
Sure. You want me to start?
Sure, go ahead.
Okay. So I'm Barbara Koenigsberg, the cleaning lady of BFK Solutions. This is Ed Koenigsberg, the rocket scientist. So I started the company back in '94, and we've worked on many, many projects to help
30 years.
to help them change, improve, whatever they need to do on cleaning, surface prep, residue removal, all of that good stuff. Everything from fine arts to electronics to medical devices to missiles. I have a background in biology and biochemistry. I come out of the old Litton Industries.
I've got a background in physics and did quite a bit in aerospace R&D.
Which means when he and Darren get to talking together, nobody understands them. It's so much fun. So yeah. Very happy to be here, and thank you folks at Hubbard Hall for organizing this.
Thank you, Barbara. Darren?
Hi, I'm Darren Williams, a leader of the cleaning research group here at Sam Houston State University, which is the research group with my students, and we research solvent blends and aqueous formulations and so on. I started in cleaning when I got my job at B&W Pantex, and back in '98, I started working with them as they were cleaning components out of the nation's nuclear stockpile. And so since then, I've been sort of building my niche in cleaning research.
Great. Thank you, Darren. Darren, at this time, I'm going to actually ask you to open up our first poll question to the attendees.
Sure. Okay, you should see on the screen a poll pop up, and it's sort of just gauging the interest of the group here. Increased regulation of one of these solvents will have a large negative impact on my business. Actually, you can select all that apply, so you can go down and pick all of those. And if you're just curious about the changes in solvent regulation, we've left you a box to tick. None of these, I'm just curious. Looks like PFAS is in the lead.
Whoa.
Yeah.
Yeah.
Okay. I'll end the poll and you can see the results.
Huh. Well, additively, if you add up MC, n-propyl, and all the chlorinateds, it's kind of neck and neck, isn't it? Or maybe a little higher. Yeah.
Yeah. So again, a lot of spread, and we didn't force anybody to just choose one. So That's
Right.
our poll. So we have a broad interest in our audience today.
Perfect. Thank you so much, Darren.
Yes.
So my first question for the panelists is, what are the the latest EPA activities and proposals that are going to be impacting the cleaning process? And Barbara and Ed, I would like you to start this discussion. So
Yes, absolutely. We will summarize a little bit.
yeah,
Yes,
Because this can go
because
on.
we're only on here for an hour.
Yes. However, I think in the poll, most of you should have said all of the above, possibly, especially if you have a complex build. So there are 2 nationwide, that means not just the LA idiots over here in California, but nationwide activities that will impact the way you do manufacturing. One is called EPA amended TSCA, and it relates to the Lautenberg Chemical Safety for the 21st Century Act. And the second is, of course, PFAS. EPA is charged with enforcing Lautenberg. They are responsible for looking at risks, not only to the environment, but to workers. So the chlorinated solvents that were on your list of concerns are right there in that first group of 20.
And brominated.
And brominated, yeah, and
Yeah.
propyl bromide as well. The short answer is we don't know for certain what will happen, because the first final rule covering methylene chloride is due to appear in the Federal Register tomorrow.
They announced it today, just about an hour and a half ago, that it will appear in tomorrow's Federal Register. This is the final rule, and almost all uses of methylene chloride are going to get canned.
So does that mean something else might happen? I don't know. Nobody knows for sure. It's kind of like the Rolling Stones farewell tour.
Yeah.
It may go on, but things are already happening. One of the reasons we're concerned about it is not just the allowable uses, but even if they're allowed, they have set what they call the ECL or ECEL, allowed worker exposure level. They look to be going orders of magnitude lower than what any federal or state or even California agency is thinking about.
Hey,
There is,
Barbara,
Yeah.
if I could just to quickly differentiate, Ed, you did mention all uses of methylene chloride. I think there was some delineation between consumer uses versus industrial and commercial.
there are.
There are a few industrial uses that will be allowed for up to 10 years. I think, for instance, critical uses by NASA. However, they will still have to adhere to the limit.
In the monitoring, right? The increasing
A lot of
monitoring.
monitoring, a lot of proving that you can reach these absurdly low levels. We've summarized what we think the levels are in some of our newsletters. And if you go to BFK Solutions, go to the newsletter archives, you can pull out the articles. I've left them up there. So that's one thing. And that takes it's a lot of similar solvents, and they have utility for manufacturing because they have good solvency properties, so they get all the heavy greases and oils. They work well getting into nooks and crannies, and then they evaporate and go away. Okay. The EPA amended TSCA is also looking at trans 1,2-dichloroethylene, which is the only related commercialized compound in good use that is left to use, and that is in the next group to be evaluated. Beyond that, trans has to be controlled because it can catch fire. Pesky flammability. Well, they control that by using HFCs, HFEs, and HFOs, and the biggest things with all those fluorinateds is that they fall under the auspices of PFAS. That is a ginormous, confusing mess that encompasses federal and state levels because measuring them is very difficult. The specificity is difficult. It becomes guilt by association. What has happened with that, with all of these activities, is that one major manufacturer of
Okay, fine.
trichloroethylene has exited the US market. What does that mean? Shortages. In addition, we know that 3M exited production of anything with the PFAS in it, including the solvents that we all know and love to keep trans from setting the place on fire. So we don't know for sure. There are definitely some in-kind, very similar substitutes for the inerting agents that'll be available for at least the short term.
Mhm.
So it's rather complex. We don't know for sure how similar we're going to be able to be, and the less similar the solvents, the more you can run into trouble. And I think we're going to talk about that in just a little
Yeah.
bit.
Mhm.
Let's see. Have we taken a 5-minute wander through that? I have
We
tons
have
to.
taken a very good 5-minute wander through that, and we have a couple more minutes left on this question. If anyone else wants to jump in, if not, I can move us along to our next question here.
Well, I would just say the uniqueness, I think, Barbara, you and Ed and Darren as well, over the years, over the last number of decades, it was always the auspices of OSHA, Occupational Safety
Very
and Health
important.
Administration, that would regulate and that would monitor the exposure level of employees in the workplace. This is out of the Lautenberg, was it 2016, I think, the Lautenberg Act?
Yeah.
Yeah.
Mhm.
So the
Chemical-
uniqueness of this now is that EPA now has determined the unreasonable risk of human health of some of these solvents, which is real. EPA was always environmental and groundwater and air and everything outside. And they're really delved into the, what's unreasonable risk for human health, which is interesting.
And that is very important because many of the substitutes, while very good and while they can be used safely, have not been studied as much as the ones that the EPA is getting all exercised
Yeah.
about. And of course, we need to protect workers, but I don't like the idea of telling workers to effectively stop running in front of this truck, go run in front of that truck. We don't know what we're changing around to. We're of the firm belief that all chemicals have to be handled respectfully, and there can be human and environmental effects that will show up, because if the chemical actively removes soil, it is going to impact us because we are all made out of the same building blocks.
Mhm.
Well, I think that's a great point, Barbara. I was looking through the EPA announcement, and I think they did specify, obviously, the consumer aspects of methylene chloride specifically.
Yes.
And in retail applications where homeowners could have bought a paint stripper that was based on methylene chloride for something to strip paint in their home without having ventilation and without having protection.
Yes.
So I think none of us want to see that level of
No, absolutely not.
among
Absolutely
consumers.
not. Absolutely not.
But to your,
Yeah, go ahead.
I was just going to say, Barbara, to your point, all these solvents are extraordinarily efficient at doing what they do best, and that's solubilizing oils and getting rid of contaminants off of very precision, metal parts, whether it be aerospace, military, medical. Do a very good job in the right equipment. So I think it's a matter of maintaining that solvent in the equipment so that people aren't exposed to it. So, we're all for limiting the exposure to people at their home, but I think there are, the reality is, like you said, these chemicals have been studied for what, 40, 50, 60 years, I think.
More than that.
Yeah. So I think
Yeah.
that level of investigation, I think, has led us to where we are now, that let's make sure we limit the right chemical for the right process in the right equipment.
So Jeff, I guess I'll ask our next question, kind of good lead into that, is with all of these bans and restrictions, what chemicals or processes can manufacturers use for cleaning, and how are they going to know that they're still getting that achievable, reliable cleaning that they've kind of come to rely on for their end users?
So you're
Yeah.
saying what are the what can
What
they do
are they? What
versus
chemicals or processes
What's
can
that?
they use?
Tomato.
What's next for them?
well, the natural progression or the natural reaction has been over the years, and Barbara, Ed, Darren, you can validate this. we've gone from solvent to solvent to solvent, always looking for the next best, safest that will do what they do well, clean efficiently, dry efficiently, and they're infinitely recyclable, which means they're sustainable. So everyone is looking for the next silver bullet, if you will. And could that be aqueous? Could it be modified alcohols? Could it be fluorocarbons or hydrocarbons? What's the answer? And I think it's a blend of the right chemical, the right equipment, and the right process. And if aqueous is an answer, I think you have to do all sorts of testing on the configuration of the parts you're trying to clean, and primarily the contaminants or soil you're trying to remove, as well as the energy that's consumed, not just to clean these parts, but then to dry these parts. And what kind of a footprint do you need equipment-wise to contain all of that inside of the building? So I think that becomes a lot of the reality is there's so many different facets, Shelley, that you have to evaluate everything, not just will this clean my part, but will it be able to be integrated into my process?
Yeah.
Well,
Part of,
actually, we have a short list. Could we,
Sure,
you could tell me if we screwed up on this short list of what we came up with. One thing that's very popular is the modified alcohol. And I always think of a mixed drink with a cherry and an umbrella in it. That's not what they mean. It's a longer chain alcohol with an ether blend in it, I think, a bond in it. So it's got more of a hydrocarbon in it. There are also the isopars, the hydrocarbon blends. There is a low boiling halogenated solvent, Solstice, which I can't give as anything but the commercial names. There are an assortment of bio-based materials and other products that have a very high boiling point and then need to be rinsed. But if you take away the PFAS material, what you have left to rinse them with are low flash point solvents. And there are an assortment of low flash point solvents like isopropyl alcohol, ethanol, even acetone. With all of these, sometimes you will have to use a blend, several different ones in a row. You have to look at a number of things besides the insurance aspect, because some insurance companies frown on large vats of acetone sitting around the plant, because it's rather explosive. But you also have to look at the general, how well do these work in the process? And it keeps getting lost within the concept of what's left, what do we have to do to comply? It's, can we make this process work at least as well as or better than the predicate process, better than the process we're using now? Of course, that gets particularly important in what we like to call safety, what the EPA calls safety critical applications. We call applications where if you get it wrong, airplanes drop out of the sky or people's cushions fall off, or both. And you really have to look at the end use and the consequences. So you folks have to look at what's available, and that's what we all help you with. What's available? Is it going to remove the soils well? Or is the combination process, is it going to interact with the materials of construction? That's called materials compatibility.
Can it get into the material of concern also? Because
Sure.
Especially with complex shaped objects with lots of nooks and crannies. There are limitations, for instance, with the high surface tension of water, which is one reason why you tend to add a surfactant to help lower that surface tension. That may help get the water into the part, but then how do you get it out?
That's right. And how do you keep that surfactant from staying behind? Exactly.
And the modified alcohol works for a lot of stuff. It does have a higher viscosity. It's not like honey, but compared with perk, it's kind of more like honey.
And a higher boiling point. You're not going to, there's really the thing that I've taken home from this is there's really no drop-in replacements anymore. I mean, there's going to be, you're going to be looking at some sort of different equipment, especially if you're still using an open top vapor degreaser. That I don't see any way to move forward with a long-term solution where you will be able to have only air between your nose and the top of the solvent. That you're
Yeah.
going to have to go, and that's where it becomes very confusing, because there's sealed systems, there's airless systems, there's vacuum systems, there's systems that do vacuum cavitation and cyclic vacuum. So trying to figure out what these new terms are and so on, it can be very confusing. And so you've got to reach out, you've got to get informed about all of these different options.
Now, I would ask the follow-up question here of how does a manufacturer know that they're receiving that same level of cleanliness with a new solvent or a new aqueous chemistry?
Oh, that wasn't on the list of, all right, no, okay. Can I take that a little bit? Because before I was the cleaning lady, I was the Freon lady at the old Lytton. And I was always having military folks saying, how do we know this is the same as what we've used for 25 or 35 years? Because how do we know? Well, we don't for sure. It's a matter of testing to the level of criticality, setting standards, adhering to the standards, knowing your supply chain, knowing what test, how do you know you test? You don't just buy out of a catalog.
Yeah, you have to test.
You
Yeah,
have to test, and that
Barbara,
means
I've seen people, just as a sidebar, I mean, coming out of your aerospace or military applications, there are some companies that do 100% inspection. I mean, so to your point,
Sure.
how do you know? They will test every single part to make sure it is, because as you said, Barbara, you don't want to have critical components on an aircraft or a fighter jet that can be compromised as a result of some contamination bleeding through a joint in the weld or something.
yes, that's
Right,
and
so-
where you're building a part and you have multiple materials of
Right,
construction.
right.
100% inspection is important. Visual is really important. And
And I think there's also surface analyzers to test whether it's a
but what is
diamond
it
test.
analyzing? Sometimes
Well, I think,
you have to extract, Jeff.
yes.
You
No,
can't get in there. It's all, if the part is all surface,
Right.
like on a lot of the 3D printed metal parts, a lot of the medical devices are made to grow in, so the bones grow into it, or
hopefully.
yeah, no,
Yeah.
anyway, basically you really have to set up programs, and in fact, Ed and I are on an ASTM committee to the unofficial name is dealing with creeping residue limits, because everything's is exactly the same except that it isn't. And how do we move forward where there are complex supply chains?
Mhm.
Anybody that wants to help, give us a call, please.
All right, Darren, at this time, can we open up our second poll question, please?
Certainly. So the second poll question we have in response to these increased solvent regulations, I'm exploring the following, and you can select all that apply. So are you switching to a drop-in replacement or solvent or blend? Are you switching from an open to a sealed solvent cleaning equipment that could be sealed or vacuum or cyclic vacuum? Or maybe you're switching from solvent to aqueous, or I don't know why, but going from aqueous back to solvent, maybe there's a critical component you have to look at. And so that's great.
We see that all the time.
Yeah, that's right. I mean,
Yes.
solvent, sometimes the small spaces and so on, it's just it's the only economically feasible way to go.
Well, I
That-
think
So they're
obviously
coming in. We have
these, Darren, are questions that everyone's asking every day.
yes,
Absolutely.
I think over the past 40 years, at least in my experience, that people have become spoiled that the certain products and certain chemistry will clean almost anything. So they've always tried to do that. So I think you're going to have to differentiate.
Yes.
yeah,
Yes.
that's right. So here we are. So the plurality here is looking for some sort of replacement solvent or blend, and like I said, that would be ideal.
If there is one.
Yeah,
So
that's
I'm
right.
guessing people are talking
Yeah.
about the trans DCE azeotrope.
Mm-hmm.
Drop in is in quotes for several reasons.
That's right.
Even that you folks need to look at, because the boiling point is lower.
And you still need to test.
Test, have a look, see at it.
Yeah.
That's right. Okay. Thank y'all so much for participating.
Yes, thank you. So our third question is a bit on the follow-up and solvent alternatives. And Jeff, I know that we've been talking a little bit about aqueous, moving to aqueous. Can you give our members here that are listening in on any success stories that any companies that you know of that have moved, completely from solvent to aqueous?
Sure.
Yeah, we've over the years, I mean, most recently, we have had a number of companies. Everyone has obviously tried to find the holy grail, if you will. Give me something that can clean everything, that is not going to break the budget, in equipment that is sustainable, that we continue to reuse. But we have a few companies that have done different infrastructure for automotive and aerospace that have gone through significant testing to get off of what, this is a couple of years ago, off of trichloroethylene, TCE, which was under the gun initially for quite a while. And what they've had to do, obviously, is replace the equipment, number one, but their equipment needed to be replaced anyway. So it's the equipment and the testing, as Barbara had mentioned, that you have to make sure that you're going to be able to clean that. And like Ed was saying about the surface tension is critically important, because the solvents were always used for a number of reasons. They're infinitely reclaimable. They have low surface tension. They're non-flammable, and they're aggressive cleaning agents, all of which made it so they were easy to clean anything. Nowadays, so this company I'm thinking of locally that had changed, they had to go through and differentiate what parts they could go through aqueous cleaning and what couldn't, because I'd seen companies in the past that tried to be cleaning circuit boards with aqueous, and then the nature of the beast was the components are so close to the surface of the board that water would not get in there to remove the contamination. So we have seen some success, Shelley, and I think if people are committed to it, there are ways to find it, but it's going to be a combination of testing the contaminants, making sure you're cleaning the parts that need to be cleaned, and they're compatible with the materials of construction. And the fact that you have to figure out, one thing you see in solvent is they're infinitely reclaimable, and you're always able to remove the soil fairly easily compared to water-based systems. Because water-based systems, now you have to go through wastewater treatment. So there's a lot of things to consider, and time and money are obviously one of the most important things.
Thank you.
And that is our very first step. We're doing an aqueous switchover research project right now, and we're testing all of the soils against a panel of surfactants. And if we can't move the soil from one vial to another, I mean, if you can't clean a vial, you can't clean a part. And so this initial testing on your soils is not something that is overly burdensome. There's a lot of samples, but it's not like you have to build a whole new system just to test it. You can test the alternative chemistries quickly and fairly inexpensively.
And you raise a really good point, Jeff, that you have to be able to access the part or fixture it so that you can access the part. So where you run into problems with electronics, I saw it first back in the late 80s, early 90s. I was in high school. Back in aerospace, and we were able to successfully make the transition if you had above 5 mil standoff or above. You could get decent cleaning, decent flux removal. Anything below 5 mils, it started to get into the silly season, and it was very difficult to remove it. One thing that I think, and we may be transitioning into the next question. Yeah, well, I talk about it now. You have to be able to spend the proper amount of money on the equipment so that the chemistry accesses the part to be cleaned. And the biggest problems I see, I'm going to be prejudiced, is if the MEs buy the equipment out of a catalog because it looks real sexy and terrific, and then go to the chemists and the assemblers and say, okay, you make it work now. Never happens, does it? Or the manager says, ooh, this is a cheap piece of aqueous cleaning equipment, let's buy it. Everybody says that the catalog says it works really well. Good aqueous cleaning equipment costs some money.
Any good equipment, whether it's aqueous
Absolutely.
or
And
solvent.
you should buy aqueous where your group, the assemblers, the chemists, and the and mechanical engineers and the
And
and
And the
safety
waste treatment people.
waste treatment and the
Mhm.
water and the people in charge of chemical quality, because water is a chemical.
Yeah,
That
Yeah.
all has to fit together. That takes some work and that takes some time.
Mhm.
and you need to test. And
You
then
need-
you need to test some more.
And even with water base, you probably want to protect the worker from the cleaning agent, because you're heating it, you're spraying it. You got a lot of different workers. And
And most water aqueous products are not pure water. They've got chemicals in there as well. And you've got to be concerned about what are those chemicals going to do to your parts and to you.
I
Mhm.
think we see the best results where the folks we work with sweat the small stuff, and they allow us to help them sweat the small stuff. That's basically where they have the most success. Where they have the least success, I'm going to blame the MEs, is where they tell the MEs to pick out the equipment, and us poor chemists have to figure out how to make it work. You can't pick it out of a catalog.
Steph, anything from your standpoint on kind of what changes an organization should be expecting as they're going through any sort of change, or related to like cost or stress that they might impact in their
You know what?
operation?
I'd say what's interesting, Shelley, and we've all seen this in the last, it seems like in the last 4 years, we've had a number of these echoes have come out of EPA related to minimizing exposure to magnitudes less than OSHA had prescribed.
Way less.
Way less. So it's very difficult to achieve any of these exposure levels in current equipment. So and I think I had heard a number recently that there were 40,000 vapor degreasers in the United States. So if you think that there's that many, think of how long it's going to take to replace all of those. With vacuum degreasers or much more efficient machines, you could be looking at 20 years to replace all the existing equipment that's in the field. And all of that equipment, whether it's vacuum degreasers, emissionless, like Darren was speaking of earlier, are expensive. 500,000 to $1 million is not out of the question. And I imagine the lead time is not going to be 8 to 10 weeks. It may be more like 12 months, 18 months. So I think that becomes, it's the supply chain, supply and demand, and people all trying to achieve the same goals at the same time is really going to be the driving force. So I think going forward, and I did see a question someone was asking about the next, I mean, right now it appears, as Barbara had said, that modified alcohols are not really being pursued, if you will, by some of the government agencies. The only issues we have with the modified alcohols or hydrocarbons is they're combustible. They have flash points that are lower than their boiling point. So they cannot be dropped into any vapor degreaser. They have to be in a vacuum degreaser. And that's the only way. So a vacuum degreaser increases the cost of that machine 10 times maybe, or maybe more. So I think if the solvent doesn't get out of the machine, it's not as big a problem, but I think it's critically important if it's flammable. So that's really what I'd say on that.
Yeah, it does increase the cost of those machines, but there are a lot of benefits that come with that. So that's what I was saying about looking at the whole process. When you have those machines, they, by definition, they recycle those solvents and they, redistill. So you do have a lot of benefits. And I'm not selling any of those pieces of equipment. I'm just looking at the science behind them. They're fantastic. But again, the lead time, I mean, you said maybe a year, but that would be a year for delivery. Then you've got to test and validate and all of that. And it gets really extensive, especially if you're working with something in medical
or aerospace, or even high volume consumer. It may not be as a big of a societal cost if a consumer product fails. However, It's not good for business.
Yeah.
It's a mess. I think one of the concerns that we both have is that there tends to be a never-ending cycle. And we switch to a chemical because it works. Then the EPA looks at it because it's becoming more in use. Then somebody somewhere uses it improperly, which is inevitable. Just like there can be construction accidents, there, unfortunately, somebody can do it wrong. And then there's a big to-do because chemicals are mysterious. So it frankly becomes akin to a witch hunt. And everybody says, we will make the world safe for democracy by getting rid of this chemical. And then manufacturers move to another chemical because it works, and on and on and on. And I think somehow we've got to get some realism from the regulatory world and from our lawmakers. Come on, you attendees, we just have to change the EPA and Congress. Not a problem. It's a gradual thing.
Oh, is that all?
Is that all? But I think that the atmosphere simply has to change. And I saw it from back in the late 80s because I knew nothing about manufacturing processes. I had a background in designing blood tests, so I had a good analytical background. And they sent me over to the old timers then, who told me about the same sort of story, that there were more and more and more restrictions. And it's a problem. And every time we go through this exercise of attempting to ban or restrict chemicals, it's a great deal of upheaval. Many chemicals can be used safely in the proper equipment. And that includes the one that have these, in my opinion, ridiculously low worker exposure levels. It's just my opinion.
And my opinion is that many workers can be protected with PPE, but that's sort of been taken off the table. Because the validity of PPE seems to be completely discounted.
It's good to a point. It has its limitations because it's something that has to be active. It has to be actively done each time, meaning you have to put on a respirator, you have to be trained in it properly, you have to, the respirator has to be in good shape. It can be used. In some instances, it might be used. But anything that keeps the worker and the chemicals apart is great.
So
Yeah.
I want to ask you guys a question about how would a manufacturing plant ensure compliance without compromising on competitiveness when they're making
sorry,
all of these changes?
Oh, so back during the Great Freon Festival, a number of large aerospace companies, then I will not, and it wasn't just one, it was a number of them, said to the EPA, yes, Mr. EPA or Ms. EPA, we will comply with whatever you have. In the Southern California area, they said, yes, South Coast Air Quality Management District, we will comply. You know what happened in the late 90s, mid to late 90s to early 2000s? Industry left California big time. After the restrictions on the older Bush, they basically said we're going to stop using Freon within a 1-year time frame. People said, of course we'll do it. And you know what a lot of the companies did? They set up overseas plants.
Mm-hmm.
I don't want to see any workers unprotected around the world. We are all citizens of the world. But I'd like to see a little bit of locavorism, as it were, that we, like the farmers market, you know, we should be able to do it safely in the US.
I agree with that. And I think also when we consider what's happening when these processes are exported overseas, they had visibility in the single digit meters.
Yes, yes.
So 9-meter visibility on a city street. We don't have that anywhere in this country. Maybe in a cotton gin.
Yeah.
Okay. But we don't have that. And so to continually to turn the screws tighter and tighter and tighter when other cities in the globe have 1 meter or 9 meter visibility. That just doesn't line up to me.
Darren, can you explain that visibility measurement?
Meaning that you can't see or define the outline of an object 9 meters away.
I see.
Yeah,
That there's so much smog and so much air
Right.
pollution.
Yeah.
Yes.
Kind of like New Jersey in the 50s. It was kind of,
Or
You
like
could
we saw
fly
with those forest fires that blew into New York,
Yeah.
from Canada.
Yeah, I mean, it's global, you're right. We
Yeah.
live, Shelley and I are in the East Coast, and we are always impacted by the industrialization of places west of us, right? Without having any impact on how we you can't stop the smog from rolling wherever it happens to go.
Yeah.
And I think that's an excellent point, Barbara, because I've been to Mexico a number of times and seen many household names that you'd recognize from the United States that have just set up shop in Mexico. I think there's many reasons to do so, most of which are economic, but I'm sure there's limitations and burdens put on them by government agencies that they just don't experience in Mexico. So they will use potentially some chemistry that we would have tight controls and equipment that will contain the vapors and the solvents much more than they do in that country. So, as you said, you can't stop the vapors from traveling wherever they're going to go, and I think we owe it to each other to be stewards of this and make sure we're using the best available technology to minimize exposure.
That's right.
absolutely. Are we going to talk about sustainability?
We are, Barbara. That was going to be my next question.
Wow.
How perfectly on cue you are.
Yeah.
So what should manufacturers be thinking about, even in ways of sustainability or ways to do more cleaning with less chemistry?
You want to start?
yeah. I mean, for one thing, I have to define what do we mean by sustainability. It's really selecting a cleaning process that works as well as the one that you were using and keeps on working.
That's important.
It's some people use the term future proof, but
Which I don't think that's possible, because hopefully we'll make advances and our product lines will change.
yeah,
So you can't completely. But I think that I hope this isn't too disrespectful, but Hubbard Hall talks about more cleaning, less chemistry. Sometimes less chemistry means a more aggressive chemical. Not always at all. We're looking at a process now that I do believe can be, off screen, can be controlled with less chemistry, with actually less chemistry and less aggressive chemistry. It's a matter of taking a fresh look. To me, sustainability has to start with the process works and it keeps working, and it keeps working reliably. That is the basis of sustainability. Now, does that mean that we have people squirting strong solvents in their faces, or even not so strong solvents in their faces? No, it does not mean that.
no,
It means that you've got something that you can do reliably. If you are going from a chlorinated solvent and to replace it, you need 3 or 4 different cleaning steps, and we've seen this.
Yeah.
We see it all the time. That to me is not a sustainable transition.
Well, I
There
think,
are- yeah.
Barbara, from your perspective of the sustainability quotient, from Hubbard Hall's perspective, kind of the tagline of better results, less chemistry means to us, if you evaluate all, like you said, you evaluate all the processes that are doing different steps in your facility. In the old days, former generations, you had a cleaning chemistry potentially that was a panacea. Put everything in there; it'll clean anything. I
Yeah.
mean, so as a result, every department would run to a vapor degreaser to clean stuff in between
Absolutely.
processes, right? And so what we're saying is how clean does it have to be? If it's in process in your plant and all it has to be is somewhat clean, so we've removed some of the oxides or the soils or oils,
Sure, absolutely.
but it doesn't have to be showroom ready until it gets out of the building.
Yeah,
I
that's a
mean,
great
so
point.
so
Yeah.
our goal is to really
Excellent.
minimize the processes that need chemistry, all the
Excellent.
while when you land on a chemical, and that's why I think the sustainability piece to me is, if I buy a pound of a chemical, how long can I continue to reuse that before I have to get rid of it?
Yeah.
Right.
I
So
think you're right. I think you're right, which relates to how effective is that chemical? Can
right.
it, can it be
Yeah, I mean,
integrated?
one of the things that hurts sustainability the most is if you have to rework the part. Because
Right.
you've
Yeah.
done the process, but it didn't work. So it's got to go back through again.
Yeah. These internal factories will kill you.
And so that's not a
So
sustainable approach.
someone asked if there were similar problems or solutions on the table in the EU. So I have not followed all of the applications in detail, and it goes country to country. I do have indication that the US is particularly stringent, and that, quite frankly, some groups are looking to move to, say, Germany. Yeah, maybe even Eastern Europe, which all of this has costs. I would like to talk about did we do all of the surveys we need to do? Because I
We
wanted
have
to
We
one
have
more.
one more poll question, Barbara, for our,
So let's do
you
that.
want to
Well, then
do
I have a
that.
comment. I have a comment about the EU after, Darren, if you have a minute.
Okay, go ahead. Yeah. You can comment there while
I
we
would
have
say,
the poll.
Barbara, we see there's a lot of industries in the US coming from the EU or Germany in particular, automotive related. And there's a lot of a lot of European automakers in the US as well as in Mexico. So we see a real advent of the next generation of cleaning equipment, the very high end
Yes.
vacuum degreasers that
Yes.
use very little chemistry, and a lot of the chlorinated solvents are strictly limited in the EU. So
Yes.
I see a lot
They're
of
limited, but not to the degree that it appears that will be happening in the US. It's more like South Coast Air District, where you can operate with what I would call a reduced pressure sealed system. They've got all different names, and you can control it. But have we done this timeline? Yes.
Well, Jeff was making one last point, I thought.
I didn't mean to. I
no, that's
was.
all I would say is that the EU,
That's-
I've seen our experience has been there extraordinarily. I'm not sure if it's trichloroethylene or perchloroethylene has been outlawed in the EU. I'm not sure.
I
One
hear
of them.
all kinds of different things, and then I don't see it because
Yeah.
it's more like a loose conglomeration of states. So it kind of.
Yeah.
Yeah. So here's the results of our poll. We've got some pretty fast timelines on some companies here.
Wow,
Yeah.
Yeah.
that's good.
Mm-hmm.
How can we help you all if you're going to switch this year?
Yeah.
Well,
Well, that's all I'd say, Darren, is that switch this year, as Ed had said, that means, or you had said, Darren, that means your order's already in place for the equipment, and then you're gonna have
Yeah.
to test. Right? So I think
That's right.
Yeah, I think it's coming, obviously, that you have to get in line for some of this stuff.
I would like to talk about the cost of process change a little bit. Is that possible? I
go ahead,
realize.
Barbara.
Are you sure?
Yeah.
Good.
Absolutely.
I keep thinking, what have we forgotten to cover in this 1/2 hour overview? One thing we should say, we've been doing this for 30 years. We have a lot of clients in industry, in the military, in schools, in museums, all
Yeah.
different kinds, basically everything. And one of our real good clients is the US EPA. So we like to say we're from the government, we're here to help. We've had a project to provide them with technical and economic information. So if something really isn't going to work, we say so. Do they listen to us? Not all the time, but that's okay. We speak very frankly, just like we're talking here today. The cost of changing the process is a lot more than the capital equipment. Wouldn't you agree, Jeff? I think.
Oh, yeah, absolutely.
Yes.
Yeah.
Yeah, and we attempted, it involves things like getting everybody together in one room and talking to each other. For some companies, that is harder than the Middle East peace talks. It's just very difficult, but it's really worth it. It's a matter of looking at the options, of getting management involved, of going to the trade shows, talking to the manufacturers, doing the testing and the validation. Some places have test labs, and if you do it carefully, you can get a pre-test of what you're trying to do. Evaluating and just basically the time it takes. Some people call it the soft costs. I think they're the more difficult
Yeah.
costs. And they can take up a sizable proportion of the budget, considering depending on the end use. So if you have only, if you think about general cleaning, that's one category. If you think about what we call precision cleaning, that's maybe has more specs. If you think about R&D work, a small company may need a more flexible machine for cleaning and may have to look into that. Then there's also the safety critical category where there are dire consequences. Redoing a cleaning validation for medical devices is awesomely expensive. And we got a number of the test labs to give us estimate. We, by the way, in our EPA contract, we have almost like a HIPAA clause. So if people will give us information and we leave their names off, and so for people where it's very sensitive, how much testing costs, how much it costs to get rid of the wastewater, some of those things, people just want to be anonymous, and we let you into our fabulous limited BFK Solutions Witness Protection Program. You don't get a Ferrari, but we leave your names and identifiers off the reports, and that's proven successful for quite well over 4 years now. So we're very, but we found out how much these things cost, and it can cost hundreds and hundreds and hundreds of thousands of dollars into the millions of dollars to do a revalidation for a medical device, for something that's implanted, a single-use implanted device. Aerospace has similar issues.
Yeah.
Yeah.
And if you have to do, if you have to do testing on every piece, that gets very expensive also.
So we have some presentations, if you're interested, where we've gone over them. It looks a little deadly dull because it's numbers, but I think it's worth looking at. It really is. I think it's interesting and useful. If you shortcut, you end up going over and over again. Yeah. Oh, I blabbed too much. Are we ready? Jeff,
Nope, I was just going to ask if there were any final questions from our attendees, because we are at about the 5-minute mark.
Yeah.
We've answered all the ones that have been coming in kind of live stream, or if any of the panelists here had any last minute thoughts that they wanted to share.
Well, Darren, I think I've seen somebody. I'm sorry.
I like the one of the costs of vacuum. Vacuum means we're talking about systems where you put the part into an empty chamber. You close the lid, you pull a vacuum, you introduce the solvent at reduced pressure, it slices, dices, purees, it does its whole thing, ultrasonics, cavitation. Then it does a bunch of rinse and dry cycles. And what you pull out when you open the chamber, you should not have any solvents on the part, and there should be no puddle of solvent at the bottom. It's just a chamber. But those systems are, it says 2 to 3 times a comparable open top. It says the process can be 50% more time. It depends on the process. Do you want to talk? I can talk to that a little bit.
Well, the process has to have certain features. I mean, sometimes you don't need ultrasonic, sometimes you do, sometimes you need, a longer drying step. So again, that would be very part dependent.
Yeah, it really, I don't want to say 50% more time. Sometimes it forces everybody to batch things and figure out what they need. So instead of having this friendly degreaser where somebody goes up and dumps the parts in it, and I used to see managers cleaning their
I think-
ties in it, you have a real controlled system.
And I think there's going to be a few companies maybe that see this as a business opportunity. If they invest in this machine and they don't keep it running 24/7 with their own process, they can then shop out some of these cleaning steps. And so there are some opportunities here. If you're making that capital investment in a machine that does all of the bells and whistles, then you may have a new business opportunity.
I think one of the bigger challenges are going to be for the itty bitty machines, where you're just
Mhm.
cleaning a few parts at a time, where it's either high volume, small production, or where people are
Right.
developing a process. And frankly, that's an opportunity for all you cleaning machine manufacturers out there. We need some itty bitty ones.
When I think you analyze this, I mean, all of this information is going to be evolving, I think.
I agree.
It's not going to get looser. It's going to get tighter and more
Nope,
stringent.
I
And
agree.
I would just recommend that you reach out to your solvent or your chemical supplier or your vendor and just figure out, what are the options? What are my options? And like you said, Barbara, some of the real tricky things are going to be, there's not an easy drop in anymore.
There's not
Right.
an easy drop in, and you do need to get everybody involved.
Right. Right.
Darren and Ed and I, we can get involved as independents because none of
Yeah.
us sell anything other than
Right.
we don't sell cleaning agents or systems. So we just, there we are.
Right.
Sometimes if you don't know where to go, a fresh set of eyes can be helpful. You folks like you who, over at Hubbard Hall, who do have an array of options, that's a great way to get started in a process change. Let's see. I
I
think.
think we've
Ooh,
hit
I
them
think
all.
we're good. Yeah.
Yeah, good.
Oh,
So thank you, Shelley,
Wait,
for
wait,
guiding
wait.
our discussion and keeping us on track with time.
we had Ed,
Um,
Ed is pointing to something.
Oh, he's pointing at something?
Can
Okay.
you read the very first question from Jim? Ed, can you read it, or I can put on my glasses?
Well, methylene chloride, TCE, PFAS are the hot topics. Looking into the crystal ball are the hydrocarbons or modified alcohols or any of the other solvents that are essentially remain going to be up on the chopping block.
Who knows? Who knows?
Yeah,
Based
my
on-
crystal ball
based
broke.
Freon and trichloroethylene Freon was introduced as a safety solvent.
Yeah.
Yeah.
It was the one that you could use with no problems.
Yeah. Well,
And then, then there was the ozone depletion, the cardiac arrhythmia, if you had to,
yeah.
all kinds of interesting stuff.
Well, we're bumping up against a hard deadline, so let's wrap it up. And there's much more to discuss, of course. So let this be a starting point. We will be in touch with all who registered with a link to the video of this webinar and a list of our contact information for further discussion. So for Shelley and Jeff with Hubbard Hall and Barbara and Ed with BFK Solutions and myself, Darren Williams, we wish you a great rest of your day. So thank you for attending.
Thank you.
Thank
Great.
you.
Thank you. Bye.
Bye-bye.
Bye.